Okay, the record is on. So, hello everybody. Welcome to the KubeEdge community meeting. Today is 2020 March 18th, Europe friendly time. Let me share my screen so we can go through the agenda. So, just to remind that please everyone on the meeting drop a line at the attendees to give a record that you are on the meeting. Okay, so we have a few items on the agenda today. The first one is the installer improvement. So the update is that we have key admin support on CentOS already accepted. So if anyone is trying to install KubeEdge on CentOS, you can now build from the master and use the latest KadMe to do that. Okay. Any question about this one, or we can just move to the second one? All right. The next would be the. So I just want to congratulate we now have a few new approvers and reviewers to the KubeEdge main repository. The pull request, the nomination and the pull request has been accepted, started by last week and accepted on this Monday. So basically, we have four new approvers. Oh, the pull request is slow. All right, so I will just go on without the website ready. So the four new approvers are Zhang Jie from China Unicom and Dave Chen from ARM and Jen from Innovex and also Shifei from Huawei. Congratulations to the new approvers. No, the PR is still not yet loaded. Anyway, for the details about the directories of this approver are taken care, you can refer to the pull request. So the approvers are added in the owners files in these directories. And also we have a few new reviewers. Let me check if they are online. So one is Feng Yunpan. I don't know which company he worked for, but congratulations. And also thank you contribution. And also another one is from Su Xiaoling from China Unicom. Okay, so I just want to add that in the long term, we would encourage people, basically contributors, to apply for membership by themselves. So if any of you have any question about the process, you can refer to the membership document, and also you can refer to this pull request as an example. You can use the reference links listed on the pull request. Oh, it's still not yet loaded. Basically, you need to list your contributions to the project, including pull request you authored, pull requests you reviewed, and also issues you reported, and also issues you commented. And there are other details about the responsibilities and the privileges of each level of membership. You can check out the membership document in the community repository. Okay. If no one have any question, we can move to the next agenda. All right. So the next will be the actually proposal, discussion, and a review about the authentication for Edge nodes. You can open the pull request with the link attached in the meeting notes. Okay, who is going to introduce the proposal?
Okay, I will introduce it.
Hi, I think you would need the desktop, right?
I will share my desktop.
Okay.
Can you see my desktop?
Yes.
Okay, I will introduce it. The each authentication design is complete by my classmate and I. So the motivation is the current connection between each core and the cloud core. That is the authentication and other relation of the each node to the cloud requires the manual replication of the certificate, which have poor scalability and flexibility, and the root certificate is not within the Kubernetes native authentication and authorization system, and it requires additional maintenance. The goal is that to implement the each nodes automatically apply for certificate when joining the cluster. The Kubernetes API server approves the certificate, then they can establish mutual authentication TLS with Cloud Core. Let's see the design detail. We implement the auto authentication based on KubeEdge installer key admin. The design idea is to reuse the Kubernetes authentication. I put the picture on the left. So I will introduce each step. Each step in the picture is described as follows. Step 0. Once Cloud Core starts, Cloud Stars applies to the API server for cluster info, config map, and the token list. The cluster info config map is for each core to verify the API server, while the token list is ensure the token of each core is valid. So to have the each core trust the API server, step 1 and 2. After running key admin join, key admin will ask the Cloud Core for cluster info config map. Then the Cloud Core will respond. Step 3. Each core calculates the hash code of cert to compare with the flag discovery token C cert hash to identify the API server. To have the API server trust each core, we should do this. Step 4. Each core will create a CSR if they are the same in step 3. Then each core will send CSR to Cloud Core with its token. Step 5. Cloud Core then compares the token with token list. If it's in the token list, Cloud Core will create a new client with token and CA to communicate with API server. Next is forward the CSR of each core to the API server through the client above. If it's not in, Cloud Core will ignore the request. Step 6, API server sends the CSR to the component controller manager. The controller manager will approve the CSR. And step 7 to 8, the Cloud Core forward the certificate to the each core. Step 9, each core sets up a mutual TLS authentication with Cloud Core. And step 10, the Cloud Core communicates with API server through HTTPS. We should note that let's see the step 4 and step 9. In step 4, each core sends a CSR to Cloud Core based on token, while in step 9, each core communicates with Cloud Core through a certificate. They are different. Compared between step 5 and 10. In step 5, client is created by token and CA, while in the step 10, client is created by original KubeConfig. Because KubeConfig has more permissions, but client with token can only make a CSR. That's all. Thank you. Hello?
All right. Thank you for introducing the proposal. Any questions about this proposal?
Hello. The key admin init command will generate a token. Then we can use in a join.
I'm sorry, can you say it again?
Hello. The key admin init command, I think it will generate a token, right?
Yeah.
Yeah, I think seems. Oh, okay.
It's similar with KubeAdmin.
Okay, when we execute the key admin join, we will use that token.
Yeah.
Okay.
Hello? Hello?
Yes.
About step 1 and 2. Key admin how to ask the Cloud Core for the config map. Use HTTP request.
He can use HTTP short connection.
Okay. Is it safe?
Mm-hmm.
So I think you need to highlight the. So basically, Changqi is asking about step 1 and 2, right? So the question was, is any encryption or security method during these steps? Right?
We think we could design a new HTTP server to receive the request for cluster info and transfer the request to API server and retrieve the cluster info and send the cluster info to KubeEdge. The key step is we should create a new HTTP server. And the point is that we also has a question is that how can WSS server could serve different requests. The first one is the normal connection between edge core and the cloud core, such as stamp 9, and the second one is the stamp 1. It's a request for cluster info. We have tested that API server could serve different requests. We can use certification to send the request to API server, and we can also use no certification to get cluster info. So we don't know how API server do that, and it's the question. The plan 1 is to create a new HTTP server. The plan 2 is to ensure the cloud core WSS server could serve different requests. Any problems?
So I just want to add that Regarding the proposal, you may need to give a brief introduction about the implementation in KubeAdmin, because you are kind of referring to the KubeAdmin node authentication steps, right? Especially for the step 1 and step 2 to fetch cluster info. You may also need to just briefly introduce what kind of information is included inside the cluster info. So basically, the cluster info, if I remember correctly, it's just a public search, public CA of API server, right?
Yes, yes.
So so basically, even this step is not encrypted. It's kind of still okay, because the first time when you access a website, the first step is always to get the cert, right? And it's kind of static information during a period of time. So, and also the information is minimal.
I think we can add something to this spec to explain why it is secure, why it doesn't matter. Maybe that will be help us to understand this design better.
Yeah. Okay. Any questions? All right. And also, by the way, for a proposal, you may need also include the development plan. So basically, like initially, we may want to have alpha release in 1.3, and you may also include the criteria how this feature can move to beta, and also estimated time, like 1.4 or 1.5, and also the criteria for moving this feature to stable.
Okay. Thanks.
Yeah, and also to complete the proposal, you may also include some of the alternative options. So basically it means the other ways of the whole mechanism you considered. It doesn't matter if it's not finally used in this proposal, just to let people know you have done a lot of research and also considered several approach. Okay, that's all from my side. I think it's good starting.
Okay.
All right. Any comments about this proposal, or we can move on? All right, so I guess people may need more time to take a detailed look about this proposal. So let's move on to the next. It's demo show controlling LED lights with KubeEdge from the cloud. Shufei, would you like to start sharing?
Hello.
Yes, I can hear you.
Okay, I will share my desktop. Hello, can you see my desktop?
Yes.
Okay, I will show the LED light from my camera, 4 cameras. Okay, can you see the light now?
Yeah.
Yes.
Yeah, you need to see the light from my camera. Okay, so I will introduce how to control this LED light from the cloud. Use the device API in KubeEdge. So first let's see the device CID. Okay, so first, if you want to control the device in the edge node, you first need two CID. First is the device model. Another is the device instance. So let's see the device model. Okay. In the device model, we define some properties of the device. Like in this traffic light example, we define the light red, yellow, and green. This is the status of the light. Now, first, they are all in a turn off status. Okay. Yeah, this field, this properties is the pin number in the Raspberry Pi. We know the light is connected to the Raspberry Pi through the wire. So we need configure the number in the cloud. So the application running on the edge node know how to control the device, the light. Okay. This is a device model, and another is the device instance. Let's see the device instance. In the device instance, we define an instance of this light. This is the device model ref. The second is the node selector. It shows which node the light is connected. In this demo, the edge node is the Raspberry Pi. Then the status is the status of the light. First is the red light, the yellow, and the green. Okay. When we create the device model, the device controller will create a config map. Let's see the config map. In the config map, let's see the config map. Okay. In the config map, it will include all the information about the device, like the pin number. This config map will send to the edge node. So the application run on the edge node can use this information to control the device, the light. So let's see the application. This deployment will create a pod. This pod will run in the edge node. It will control the device. Okay, let's see the pod. I have created. Okay, this pod is running. Let's see the node. We have a Raspberry Pi. This is a edge node. Okay, from here we can see the pod is running on the Raspberry Pi. Okay. So next, let's use the device CID to control the light. This is a device instance. Let's control the device. Okay, you can see first the 3 lights is all off. Let's turn on the red. Okay, we can see the red light have turned on. Okay, so let's turn on another. Let's turn on the green. Green. Yes, we can see the green light have already turned on. We can also turn off it. Okay, you can see the red light have been turned on. Okay. You can see in the status, this is a device tree. Device tree, we have 2 fields. First is the desired, another is the reported. The desired is the status we defined in the node. The reported is the status reported from the edge node. First, if we want to control the device, we need to modify the values in the desired. Then the edge node will report the status from edge node. Yes, if we turn on the light, then now we define the status from cloud is on, but in the edge node it's off now. You can see. Okay, now the edge node have reported the status. It's turned on now. Okay, that's all. This small demo about the LED light. And we have pushed it to the example repo. If you want to try, you can do the example. That's this PR. And the demo is written by Angie. Okay, that's all. Any questions?
Thanks, Shifei, for the demo. Any questions? All right. If no questions about this demo, maybe we can discuss the other things.
Okay.
Anyone have any topics want to discuss? Okay. So maybe no updates. So we can maybe just go briefly through the 1.3 release development. Recently, I have updated all the ongoing pull requests and the issues to under the milestone 1.3, and also the bug fixes is not included. Okay, so currently the one closed is the declared me support on CentOS, and we are still the others are still under development. So we went through the node authentication proposal today, and for the kube control logs and the exec command, we went through the proposal the week before. I think maybe next time we can check out the updates on this one. So for the refactor of edge mesh, we have one initial proposal, but it looks like there are some conflicts on the pull request, so we need to refresh that. For the CRIO runtime integration, Dave, do you have updates?
Yeah, I have go through some code about the CRI in the Kubernetes and also in the KubeEdge project. So I found that most of the code and the implementation has already created. So most of efforts I think will be the validation. So I have not start to validate those lightweight runtime, but I will kick off the task soon. So when I get some update, I will post on the under this issue.
Sure. So another big thing, not yet on the list, I think, is the HA for the HA for the cloud core. We will need to create the tracking issue or directly start the proposal. Maybe tracking issue first. Okay, for Golang 1.14, I think we may need to hold this pull request for a while because there are some issue still not yet, performance issues still not yet resolved in in 1.3, 1.14. So we will probably hold that for a while until upstream fixed that. Anything add to the release updates?
The HA of the code call we will add to the 1.3 main.
Yeah. I will just add a note here. Oh, by the way, for the improvement of the installer, we will still need an umbrella tracking issue.
Okay.
Anything else? Or maybe for the metrics, right? Okay.
So I have a question about the metrics. Does KubeEdge support the metrics right now, or is just it's a feature in the pipeline?
The metrics currently is not supported, so we plan to do it in 1.3. Because the metrics will also need some streaming data. Maybe not streaming, but just the period of time the control plane will start request to fetch the data, which in the KubeEdge scenario is quite different because the edge nodes may locate in the private network or behind the firewall. So the mechanism may be different. So we need to figure out a new way to implement that.
Anyone is on that?
I think Shufei will work on this, right? Anyone interested in joining the effort?
Maybe I can take a look at this, but I'm not sure I have any efforts for the 1.3. Maybe we can play this to the 1.4.
Yeah, that's okay.
Let's see.
Yeah, let's see. Anyway, we will start the design proposal and at least make the proposal solid in 1.3.
Okay.
Okay. Anyone have anything want to discuss? All right, so the next time the meeting will be March 25th, the Pacific time, right? Pacific time. Okay. Any people want to discuss anything? Otherwise, we can finish the meeting today. No? Okay. So We have 13 minutes for all the attendees. Okay, thank you everybody for attending the meeting. So the meeting next time will be the Pacific time, March 25th. Take care until next time.
Thank you. Bye-bye.
Thank you.
Thank you. Thank you.
Thank you. Bye.